Okay, so we had a power outage here, and the reason is because it's an animal of some kind. We think it's a squirrel or some kind of rat. Got up, chewed on the wire, probably get a connection between the hot and the ground. So if you can see the circuit breaker on the top, it's open. See that lever arm? It should be up. Now it's down. So the circuit breaker opens. No power to the entire building in this case. So I think it probably is only the problem on the circuit breaker. It's only the problem on the breaker on the top. Great. Hopefully. I wish the little guy didn't chew any wires out. It will make more trouble for you guys.
We'll be back all day.
Yeah. That's my question. I do believe it just must cause some kind of short circuit.
Yeah, well, we would have went through the squirrel to the ground. So we went through the squirrel into the top of the transformer. So if you went up to the top of that transformer, there'd be a big black mark where you're standing.
Okay. So what did it touch?
The wire.
So probably
See the switch that opens?
Yeah.
See the wire underneath it that comes out? The black wire?
Okay.
So he touched that wire and touched the transformer.
Oh, okay. So the transformer's shield is grounded.
Grounded, yeah.
And he touches the line.
Yeah, that's right.
And what's the voltage on that line?
7,200. 7,200.
7.2 kilovolts.
That's right, yeah.
Yeah, that's what I determined it will be killed. Otherwise, if it does just touch something which is 240 volts, it's not gonna kill him instantly, right?
It could, but not instantly, not as quick.
Yeah. Then that makes sense because it established a short circuit.
That's right, yeah.
Blew everything up.
Yeah.
Yeah. I'm more interested in the engineering part.
Oh, nice,
Yeah. So it steps 7.2 kilovolt all the way down to 240.
Yeah, that's right.
Yeah. And this one is a little bit strange for this building.
Yeah, it's a big transformer. Yeah.
So it only do like one phase. I do believe more buildings nowadays like,
3-phase.
they
Yeah.
will have all 3 phase connected.
Yeah, that's right. Yeah.
Because you want the phase to be balanced.
Balance
so
better. Yeah.
you do not want to single phase anything.
Yeah.
Interesting to see.
That's what blows there. See?
Okay.
That's just sits inside here.
So how the assemble work?
Okay. Then
Yeah, it's just so fun to look at these
Yeah.
things.
So when it blows, it shoots fire out of here.
Okay. Oh, okay, so it's like literally a canister,
Yeah,
or
like
a
a
rocket, and eventually blow it
Yeah.
all
yeah
the
so,
way back.
so it'll blow the fire out.
Yeah,
This will break,
yeah,
and that lets go, and this just falls. That's what holds it up. Is the spring.
okay,
So it holds it in the door, but when that opens,
yeah.
it just falls.
So this one, okay.
Yeah.
Okay, so this is at the bottom of the
Yeah,
assembly.
that's right, yeah.
And this one goes onto the top.
Top, yeah. It closes in just like that.
Amazing.
Well,
And-
when that string breaks, this just lets go. Like,
Yeah,
that fuse
know.
holds it all together.
yeah.
But when that lets go, it just falls.
Amazing.
Crazy, yeah?
Yeah.
That's all it is right there. The whole building.
So the whole building goes through this wire.
Yeah.
Impressive. Perfect. Oh, be careful! You hit on the lamp. Okay, power is restored back on. That's how we solve the problem of a blow up fuse. It's actually a fuse up blow up. Amazing. I would say thank you very much for the employees at Nova Scotia Power. This is really a quick fix. Thank you.